What's going on, guys? Mr. Jones once again. Today, guys, I'm going to talk to you guys about Ready, Set, Go 2.2. This is going to be the classwork / homework assignment, pretty much the only assignment for the day besides some review. So I'm going to go ahead and go over an example of each section so you know how to do it. Please contact me as soon as possible if you're confused. It does a lot more good if you can contact me before we all go home for the day. So here we go. Number 1 through 6 all do the same thing. It says the standard form of a quadratic equation is defined as y equals ax squared plus bx plus c. You should already have that in your notes. And then it says identify a, b, and c in the following equations. And then it gives an example. So I'm not going to do any for free for you on these. These should all be very easy. But in the equation, y equals ax squared plus bx plus c, the a is always next to the x squared term. So there's my a value. The b is always next to the x. So let's actually make that a different color. So there's b and there's b. And make sure you take the sign with it so that positive 7 comes with it. And then last but not least, my c is a negative 6. Remember, take that sign. It's not 6, but negative 6. So go ahead and do all those problems. If you're missing a term, if you're missing one of these 3 terms, what do you think the number is going to be? 0. Good. It's going to be 0. So all of them can be 0, except for the x squared term. If you're missing that, now you're not dealing with a quadratic anymore, because remember, a quadratic has to have that x squared term. So just a heads up. All right, 1 through 6 should be good to go. Easy peasy lemon squeezy. All right, 7 through 12. So those ones are similar, but you have to multiply first. So you have to distribute, or you have to use the FOIL method, or whatever you got to do. I just want to remind you. So I'm going to do, let's just do number 10 for you. So actually I'm not going to do it, I'm just going to remind you. Remember, we're going to multiply all these things together and then these things together, and then you're going to combine like terms, and you should get an equation in the form ax squared plus bx plus c. Okay, so recall, if you see one like this, remember x minus 3 squared is the same thing as writing x minus 3 times x minus 3. Okay. And then this other one, number 12, is similar, except for number 12, you're going to have a negative sign up front. Okay, and that means that at the very end, okay, after you multiply everything together, all this stuff together, then afterwards you're going to distribute this minus sign, or this negative sign in. So after you get your answer from x plus 5 times x plus 5, you'll notice something happens. All the signs will get flipped. So don't forget this negative sign. But it's done. You can just do it at the very, very end. And that's the easiest way to do it, in my opinion. So once you do those, then you just multiply, and then you're going to get A, B's, and C's for those. All right. This next section, for some reason, trips students up. It says find a value for w such that the graph will have the specified number of x-intercepts. So think about what a parabola looks like. Think about what the parent function looks like. How many x-intercepts does the parent function have? Remember, an x-intercept is wherever you touch or cross the x-axis. So make sure that you are you think about that. So think about, what would you do to the parent function if you wanted to make it have 2 x-intercepts? What would you do if you wanted to have 1? And what would you do if you wanted to have 0? It's probably easier just to replace these w's with k's. I don't know why the heck they use w. So go ahead and just replace them with a plus k, because that's the letter that's at the back end that we've learned about before. So what could k be? And if you don't know, then just start plugging in positive and negative numbers and see what happens. Throw them in Desmos and see what happens, and you should be able to get an answer. Heads up, 14 through 19 has an infinite number of possible answers. So if you have a different answer, everyone should have different answers on those ones. All right, number 20 through, is it 20 through? Yeah, 20 through 25 are 6 different graphs, and they're all the same concept. They're all in vertex form, and so get out your vertex form notes and remember what the H, K, and the A do to the graph. Also, you should have your table out for the parent function, because remember, those are your over and up movements if your stretch is the same, which is just a 1. So on problems 20 and 21 that I have on the board on the left here, you'll notice that I don't have a stretch showing, which means the stretch is just 1, and it's the same as the parent function. So I'm going to graph 21 for you for fun, just so you can kind of see the process. All right, so off the bat on 21, notice that it doesn't have a negative sign here. So I know my graph is going to go up, face up. It's going to look like this, okay? So with that being, and also there's no number there, so I know my movements are going to be the same as my parent function. Okay, I'll draw a little table down here so you can remember. So after the vertex is 0, 0, then we go over 1, up 1, over 2, up 4, and over 3, up 9. This is the table of the parent function, which is the same movements for all graphs with the stretch of 1. So with that being said, let's go ahead and plot some points. I know normally my graph starts at 0, 0, so I'm going to put that's my normal starting location. And this says I go right 1, and this says, so I'm going to put right 1, and this shows I go up 1. Okay, so right 1 and up 1. And this is where my new vertex is going to be. So I know my vertex is there, and my stretch is the same as the parent function. So from there, just go over 1, up 1, over 1, up 1, over 2, up 4 on both sides. And if you can fit it, let's see, 5, 6, 7, 8, 9 would be up here. I'm going to go ahead and put it just because I'm a nerd. And then you would go ahead and draw the parabola better than mine. So make sure it goes through the dots. Please don't use Cam, you guys, whenever you are graphing, okay? Because you can see how ugly mine looks, and I have a pen and a little board to use. So I can imagine that yours would not look, I mean, I've seen some graphs on Cam and they don't look pretty. It's impossible for me to see if you know where all the other points are. So please do a better job than you see me do, okay? You guys should make them as nice as possible. Also, you have 6 graphs there, so at the end, what should you do to make sure you're right? Yep, you guessed it, you're going to check in Desmos, right? So toss them in Desmos, and if you made a mistake, see if you can figure out where that mistake is, because that's how we learn, okay? All right, let me get rid of this table really quick here, so just give me 1 second. All right, this next section is talking about this table, and it wants you to find the vertex, the axis of symmetry, whether it's a minimum or a maximum, and what the x-intercepts are. Okay, so I'm going to go ahead and just do number 28 for you. I don't know why I chose number 28, but that was the random one that I said I was going to do for free. So here we go. The first thing I like to do is locate the vertex. If you can locate the vertex, you could do a lot of things. Hopefully you've realized by now that all the points on the parabolas always have 2 points that are the same height. In fact, let me go over here. So you see this point and this point are the same height, this point and this point were the same height, this point and this point were the same height. They're the same heights on each side of the axis of symmetry. So I know that if I see a y value of -9 and a y value of -9, those cannot be the vertex, because your vertex is the only point with that specific y value. So you just keep going inwards. You'll see 3s and 3s, and now we get to this one that doesn't have a pair. Let me actually swap this with blue. This one doesn't have a pair, so guess what? This is the vertex. Now you're thinking, Mr. Jones, -2, -29 doesn't have a pair. Well, if you went up here, okay, you'd have -29 here, and you'd have -57 here. So they always, I'm going to erase this, but you'll see this goes with this, and they just keep going in, until you get to the very end where you hit the vertex, okay? So there's just some extra stuff for you guys. All right, so with that being said, what is the vertex? -5, 7. Now, if you have to graph it to do the rest, go ahead. -5, 7. Okay, so if I was to do a quick graph, I know -5 and then 7. So I know that my vertex is up here somewhere. And now I want to know if the rest of the points are higher or lower. If the rest of the points are lower and they're going to be down here somewhere, then you know it's going to be a negative graph, and this is if the numbers are higher. So look at the vertex. Is 3 bigger or smaller than 7? Smaller, right? So that 3 would be down here. Another one will be over here. So basically, notice without doing too much work, my parabola is going to go in that direction and obviously be a lot more beautiful. Okay, so that's the gist of what my graph looks like. Now, since I know the graph's going down, my vertex is the maximum point on the graph. That's what we're talking about. My vertex is the tallest point, so it's a maximum. Okay, if my graph went the other way, it'd be a minimum. And now my axis of symmetry is always x equals what? X equals the x value of your vertex. Notice those two numbers are the same. It's always going to be that way. So if you have your vertex, then you automatically know the axis of symmetry. Okay? And last but not least, you're looking for x-intercepts. Okay? X-intercepts. Where does your graph cross the x-axis? Well, you don't, whenever you're looking for x-intercepts, you're looking for a y value of 0. Okay, you're looking for a y value of 0. In this case, I don't see any x-intercepts. Okay? I don't see any y values of 0 in the table, but guess what? There are going to be some x-intercepts. So let me just show you this graph really quick on Desmos. That way, this is kind of what you should do. So just one sec here. All right, so what you can do in Desmos, instead of putting in an equation like I did up here, you could actually type in ordered pairs. So if you just type in all the ordered pairs that you see, it's going to put all the dots on the -6. It's going to put all the dots on Desmos. Okay, that's one way to do it. So let me put all the dots really quick. All right, so I've put as many dots as I find necessary. So all you see on Desmos is a whole bunch of dots. And so if you were to connect them, I think that you would just look for the closest x-intercepts that you could. So approximately, where do you think you're going to be crossing the x-axis? Well, one point is at -4 and the other point at -3. So you know it has to be crossing the x-axis between there somewhere. Okay, so I'm going to go ahead and draw the line, even though you can't really do that unless you have an equation. And I'm going to say, okay, I know it's somewhere between there. So I'm going to go ahead and just guess like, well, what's the number between -4 and -3? Let's do like -3.5. Okay, so if you put -3.5, -3.50, okay, -3.5, comma 0. That's a pretty good guess. And then the other one's going to cross on the other side between -6, between -6 and -7. So that means it has to be maybe 6.5 or so. Now those aren't going to be the exact answers, but those are basically points that are approximately one's right here, for example, and so actually, let's just go ahead and put those points and see what they look like. So let's do -3.5, comma 0, and let's do -6.5, comma 0, and you'll see these dots right here. So it looks like my parabola is continuing. So you'll know that it's not accurate. It's not 100% accurate. You see I'm missing it a little bit, but that's okay. The point is that you made a pretty educated guess because your table doesn't tell you where the x-intercepts are. Okay, so here's a whole bunch of things you can do for these problems. And that's pretty much it. So that's the entire assignment. All right, please contact me if you need more help, you have more problems. I'll be happy to help you. And come to office hours, guys. I would love to see you there.